Hi friends, in this video we will discuss one more hexagonal prism problem, but condition in the here the axis is inclined to VP. In question number 1, hexagonal prism solid, we discussed axis is inclined or base is inclined to HP. So if you wish to see that problem, you can check the link of the problem in the description box. And now a hexagonal prism, side of base 25 mm, axis 60 mm long, rest with one of its rectangular faces on HP. Out of that rectangular faces, here they said one of the rectangular faces must be lying on HP such that its axis is inclined at 45 degree to VP. Draw its projections. So in this, we may not simply use hexagon plane surface alone to identify the position of simple position top view. So we have to use our simple position front or top view. So we have to use this condition, one of its rectangular faces on HP. Okay, now first of all we have to be confident about longer edges, rectangular faces, edges like that. What is the rectangular face here? Here the rectangular face, you can say front surface like 2 3 CB is one rectangular surface, and C3 D4 is one rectangular surface. Similarly we can say 6 rectangular surfaces are there. Okay, 6 rectangular surfaces are there because 6 sides, each side or each edge has possessing one rectangular surface. See, 2 to 3 edge I am having one rectangular surface, 3 to 4 I am having one rectangular surface, 1 to 4 I am having one rectangular surface. In the previous video we discussed a longer edges on HP in the pentagon. So while longer edges on HP, we came to a conclusion, being longer edge on HP, one corner will touch as XY because longer edge is on the corners. Now being face, if you are saying one of the rectangular faces, it should be the edge should touches, edge must touches XY. So with this I can easily say the position of hexagon has to be drawn in the front view as one of the edges must touches XY reference line, being rectangular face on HP. In case the same question, rectangular face on HP means the one of the corner must touch the XY reference line in the front view. Now we can check what is the actual scenario in 3D. This face, see this BC32, this BC32, consider this is the horizontal plane. Okay, consider this as horizontal plane, this shaded portion as horizontal plane, this is which is lying on HP. This face BC32 face which is lying on HP with some inclinations. With this, what is the position of hexagon? See, this BC edge is on HP. So with this we can say what is the position of front view in simple position, being rectangular face on HP. I have given one more option. See, the rectangular face, one of the rectangular face is on HP. This is the hexagonal prism. One of the rectangular face, bottom of this rectangular face is on HP. Then what is the front view? If you are seeing from the here, what is the front view? Edge is on HP. Okay, edge is on HP. So how can you draw this in XY reference line? This is how you have to represent this front view, simple position, hexagonal position, simple position of hexagon. Okay, so with this we can move on to the solution. Draw XY, then fix the position of hexagon. Already we know how we obtain this position. Now position, after fixing the position, procedures are same. What is the side base 25 mm, and you can mark all the corner points. One hexagon will be visible for us, another hexagon will be invisible for us. So A B C D E F will be visible for us, 1 2 3 4 5 will be invisible, being front view it is marked as denoted in terms of dash, and base side is 25 mm. Now you can extend the projectors from all the respective corners. From all the corners, after extension of projector, you join the base. You join the base of this hexagon, and in this also again the same similar procedure for drawing the axis. For drawing the axis, Draw the diagonal, take the midpoint of the diagonal, extend the projector, complete the axis. And here you can, what is this, height, it is 60 mm. Okay, so as per the question, axis is 60 mm long. You can complete this which view, top view, and complete the axis. Give a notation for top view. If an observer is standing here, this 5 6 EF is invisible for us. Is it so? No. B2 C3 is invisible for us. 2 3 and PC is invisible from the top view. So I can clearly say this 1 is visible. And what about 2 is invisible, but 6 is visible, because 6 is visible, 2 is invisible, 3 is invisible again from here. If an observer is standing here, I can say this 2 3 is invisible, remaining all the 4 corners are visible for me. So 3 is invisible, 6, then 4 is visible. Similarly for A, then F is visible, B is invisible, E is visible, C is invisible, and then D is visible. With this, simple position of hexagonal prism is completed. Now you can tilt the axis as 45° to VP. Take any point on XY. Mark an inclination of 45° without any specific length, and it must be a thin line. Over this thin line, you can draw the axis length as 60 mm. Over this thin line, draw the axis length as 60 mm. It is inclined at an angle of 45° to VP. Now you can measure this base 1 to 4. It is 40 mm. Midpoint is 20 on either side. Complete the top view. Reproduce the same top view here. And one more thing, you have to make sure this must not touches this XY reference line. Okay, complete the top view and give the notations of the same this top view as this top view. Now you can extend the projectors from this top view and this front view. Both will meet at respective points. We can mark it as 1 1 dash, and what about here, it is 2, and 2 is on XY, 3 is also on XY. So you can extend the projector, mark 2 1 dash, and you can extend the projector from point 3 3 1 dash, and extend the projector from 4, and already it is extended, it is 4 1 dash. Then you can extend the projectors from 5, and here it is 5 dash. Similarly 6 dash is here, so 5 1 dash, 6 1 dash. Similarly, this is the base hexagon. Top face of the hexagon is A B C D E F. You can mark all the respective corners, A1 dash, B1 dash, C1 dash, and still it is common from the beginning of projection of solids. Here it is EC projector. Point E is here, point C is C dash is here, so C dash, E dash, C1 dash, E1 dash. One more corner is left out is D, D1 dash. Now you can join all the visible edges or boundaries of this view, all the boundaries of this view by continuous thick lines. Join all the boundaries of this view by continuous thick lines. This is 6 1 1 1 dash, then 2 1 dash, then 2 1 to C1 dash, then C1 dash to D1 dash, D1 dash to E1 dash, E1 dash to 6 1 dash. This is the boundary of this view. Okay, this is the boundary of this view. As we discussed, being the top face of hexagon, this entire hexagon will be visible for us. You can complete this hexagon. So E1, F1 dash, A1 dash, A1 dash, B1 dash. So the top face of hexagon is completed in the front view. Okay, and what about this base hexagon? Base hexagon, bottom edge of the base, 3 4 4 5, and 4 is completely invisible from here. If if an observer is standing here, the 4 is completely invisible. That's why it is denoted in the bracket as 4 1 dash. Now you can join these edges 3 1 dash as well as 4 1 dash, 4 1 dash, 5 1 dash as invisible. 3 1 dash, 4 1 dash, 4 1 dash, 5 1 dash is invisible. How this 1 1 dash, A1 dash is marked as visible for us? If an observer is standing here, this 1 1 1 2 A is visible. That's why this 1 1 dash, A1 dash is marked by means of continuous thick lines. But this is the bottom of longer edges 4 to D. If you are standing here, observer is standing here, it is completely invisible. That's why it is marked as hidden lines. That is the final answer of this prism. So for we discussed pentagonal prism as well as hexagonal prism with an inclination with respect to HP and inclination with respect to VP. So only thing, you identify the simple position front or top view as correct, then you can proceed the problem. All the projection of solids procedures are same. Make sure that you are, if it is an axis, you have to tilt axis. If it is base, you have to tilt base.